Reduced Instruction Set Computer or RISC instructions. To distinguish between different computers, instruction sets are the most important characteristics. Different computers have different instruction sets. There are two different instruction set architectures. 1. Reduced instruction set architectures. This architecture offers high performance in which each instruction occupies one word in the memory. The operands are stored in processor registers for arithmetic and logical operations. Load or store instructions are used to access memory operands. With a single word approach, it reduces complexity of the program. Here, pipelining method is used where the execution of instructions take place in a sequence of overlapped approach that reduces execution time of a program. The syntax of load is given as load dest src, where dest is destination address, that is destination processor register, and src is source address, that is memory location. For example, evaluate c equals a plus b. All the three variables are stored in different memory locations. The operation to execute this instruction is a plus b moves to c. Let the processor registers are named as R1, R2, R3. The program becomes load R1 A, load R2 B, add R3, R1, R2, store R3 C. Here, the add instruction is using three operands R1, R2, R3, and in store instruction C moves to R3. R3 is a processor register and C is a memory location. This instruction format usually uses load and store instructions between CPU and memory, which use only one memory and register address. If memory is not being referred, then the instructions are processed within CPU registers. To evaluate, x equals a plus b times c plus d. Load R1A, that is, m into brackets a moves to R1. Load R2B, that is, m into brackets b moves to R2. Load R3C, that is, m into brackets c moves to R3. Load R4D, that is, m into brackets d moves to R4. Add R1, R2, R3, that is, R1 plus R2 moves to R1. Add R3, R3, R2, that is, R3 plus R4 moves to R3. Ma R1, R1, R3, that is, R1 times R3 moves to R1. Store X, R1, that is, R1 moves to M into brackets X. Load instruction transfers the content of operands from memory to registers. Add and more perform addition and multiply operations, and result is stored in memory using store instruction. But how are these memory addresses specified? The user writes program in a high-level language and data is organized in a computer by using data structures. To convert any program from high-level language to assembly language, low-level instructions requires to be implemented. So the method which is used to obtain the mechanism of these addresses is known as addressing modes. On your screen, the RISC addressing modes. Register mode. With name of the processor register, operand contains the contents of it. For example, add R3, R1, R2. Here, R1, R2, R3 are all processor registers. R1 and R2 are source register and R3 is a destination address. Absolute mode. Mentioning the address of memory location explicitly, operand is also contained in it. For example, integer number 1, number 2, sum. This mode represents all global variables in a high-level language, and each variable number 1, number 2, sum have unique memory location. So the assembly language instruction code would be load R1 number 1. Here the content of memory address number 1 loads into register R1. Immediate mode. In the instruction, operands are mentioned explicitly. For example, add R1, R2, 300 immediate. Here, the value 300 is added with the contents of register R2 and result is stored in R1. We can also represent immediate value using number sign in front of value given as add R1, R2, 300. Indirect mode. In this mode, pointers are used to access the list. Registers are made as pointers and the list is accessed indirectly. The indirection is represented by parentheses. For example, load R2 bracket open R5 bracket close. Here, to execute load instruction, processor takes the value of B which is in register R5. After the contents of B are fed, the value gets loaded into register R2. The indirection mode is not valid for memory address. Its advantage is that they can be reused any number of times on different data. Index mode. Here, the effective address is generated by adding some constant value to the contents of general purpose registers. It is denoted by x into brackets ri, where x is some constant value and ri is the name of register. Thus, EA equals x plus ri. X can also be considered as some kind of displacement or offset. Complex instruction set computers, CISC. This architecture occupies more than one word in a memory, but it performs many complex operations. The instructions are not restricted by load and store. They generally use 3 address or 2 address formats. Instruction syntax in CISC is given as operation dest src, where dest is destination address or processor register and src is source address or processor register. For example, evaluate C equals A plus B in assembly instructions. Move Ri A, add Ri B, move C Ri. The move instruction has a general syntax. Move dest src, where the dest or src can be memory location or processor register. Likewise, in RISC style, the load instruction has dest be a processor register and src be a memory location, whereas store dest be a memory location and src be a processor register. Also, store and load can only be used to transfer the contents between processor and memory, but the CISC's instruction move can be also used to transfer the contents between memory locations and registers. This instruction set in CISC has 3 more addressing modes. Autoincrement mode. This addressing mode is generally used to perform operations on stack. The EA or effective address contains the address of specified register in the instruction and then the contents of the register incremented to point to next operand in memory. It is denoted by Ri plus. Suppose there is 16-bit word length. The increment amount is 2. The increment amount is 4 plus 32-bit word length. The size of the operand is already specified by instruction code. Auto-decrement mode. This addressing mode is also used to perform operations on stack. Here, the contents of a register are decremented, which are specified in the instruction and then used to compute the effective address of the operand. It is noted by minus Ri. So there is no need of these two instructions for pushing a new item. Subtract SP number 4. Move SP new item. Where SP is stack pointer, we can use only one instruction, move minus SP new item. Similarly, there is no need of these two instructions for pop item from stack. Move item SP, add SP 4. We can use only one instruction, move item SP plus. Relative mode. The index mode in RISC is defined by general purpose registers. Here, instead of using general purpose registers, program counter or PC register is used, which store the address of the instruction at current time and its value automatically incremented by 1. Thus, the EA or effective address value is known by program counter register because the address location is relative. Condition codes. Condition code register or status register record information about individual bits which are results of arithmetic and logical operations. The value of this register is either 0 or 1. There are 4 flags which are described as follows. I. N or negative. The value is set to 1 when result is negative, else set to 0. 2. Z or 0. The value is set to 1 when result is 0, else set to 1. 3. V or overflow. The value is set to 1 when arithmetic overflow occurs, else set to 0. 4. C or carry. The value is set to 1 when carry out results from the operation, else set to 0. Let us discuss the basic difference between RISC and CISC. RISC, reduced instruction set computer, whereas CISC, complex instruction set computer. RISC uses shorter instruction set, whereas CISC uses larger instruction set. In RISC, addressing modes are simple, whereas in SISC, addressing modes are complex. In RISC, simple operations are used, whereas in CISC, complex operations are used. In RISC, instructions fit in a single word, whereas in CISC, instructions fit into more than one word. In RISC, the operations, arithmetic, and logic are performed in processor registers. In CISC, the operations, arithmetic, and logic are performed in processor registers and in memory locations also. RISC loads and stores architecture. CISC moves instruction. In RISC, instructions are microcoded in ROM. CISC uses pipelined approach. In RISC, there is fast execution, whereas in CISC, execution is slow. In RISC, indirect addressing mode operates on processor register only, whereas in CISC, indirect addressing mode operates on processor register and memory location. In RISC, functionality is implemented in Pentium CPUs, whereas in CISC, functionality is implemented in Intel's 80 by 86 and Pentium microprocessor. That brings us to the end of the section. Thank you and see you in our next section.